Okay, so this is the, I don't know how to say this right. Barbasi-Albert graph. And do you remember what was different about this one?
Oh, it seems kind of like the random graph, but I think...
Yeah, here it is.
There's some sort of structure.
There are no outliers, just complete outliers, and everyone seems like this, at least to have 3 connections, I think.
Okay.
Like the histogram of the connections start at 3.
Here it's 5, it looks like.
Yeah, maybe it's 5. But
you could have a whole lot of variation with this.
yeah, and we did see that so the average is around 10, 997 over 100. But there are people who have lots and lots of connections.
Yeah.
And we could even vertex degree max. This is one thing we can do here. I'm just doing it in a separate command because printing that 3D graph takes a while. Although apparently copying and pasting takes a while. Vertex degree max. Well, that can't be right.
Doesn't seem right.
Well, sorry, I shouldn't have tried to do something on the fly, but we know there's more, the highest degree is more than 11 because of
We
we
saw
see it
100
in
plus.
the histogram. Anyway, so what do you think is going to happen in the plot here?
So this should be a lot like the random graph. It looks pretty similar to that.
Yeah, I think you were infecting a lot of people at the beginning with your first point, so I think it'll spread pretty quick. Peak will get right around the 600 mark, like we've seen before.
Alright, and here's our peak versus total.
The increase is very rapid again in total infected, but it's definitely not as rapid as the random graph.
Yeah. Okay, so having seen these 6 ones, are there any surprises?
Well, it's kind of interesting that we saw very different behavior in our first model, but in this model they all sort of exhibit the same general behavior.
Yeah. So
the model choice doesn't matter as much here.
Well, we've got to be careful about that because we might not be looking at the right thing.
I mean, it definitely has an effect, but not as pronounced, I guess.
Yeah, so from the super simplistic model yesterday where everyone just infects everyone they know, the behavior was very different, especially the speed through the graph. Here, when we limit the number of infections and that, sort of say, well, you don't infect everyone, we're just going to infect through a probability distribution. You seem to have, for every graph, you seem to have a critical point where below it doesn't spread, above it spreads everywhere. And the surprising thing is for the graphs, those critical points seem to be in about the same place in terms of number of infections per step.
Yeah.
So what does that mean about how an infection spreads then?
Well, it means that there's just either they spread or they don't, and there's just a point that you have to keep the infection rate below to prevent this from happening.
Okay, yeah, that's one very good observation. We see from all of these different types of graphs, if you lower the number of infections per step, which we'll talk about that in a second, you potentially can get to a point where the virus doesn't spread anymore. Or it doesn't spread all the way through the network. So what are some ways you can lower lower the chance of spreading?
And you've got to limit the number of connections, so just stay home, social distance.
One way is limiting the number of connections, yeah. What else can you do?
You could limit the peak, which just goes back to limiting the connections. can limit the transmission probability.
Yeah, you could limit the transmission probability. What are some things that lower transmission probabilities, do you think, for a virus, just generally?
Just like how contagious it is.
Yeah, so how can you lower how the chance of it spreading from someone infected to somebody not infected?
Just protecting yourself.
Yeah.
Yeah, protective equipment, something that prevents the virus from spreading to you or from you.
Mm-hmm.
Yeah, things like that. Yeah, so we see that those things are important just from these very simple models of virus spread, which is pretty cool, right? The math, just from these simple ideas in math, we can learn some of the important things about virus spreading.
Yeah.
It's cool. All right, good job, guys.